Hello, I'd like to talk about the impact of climate change on diseases and use of veterinary medicines. We've just recently hosted COP26 and focus is very much on the UK in climate leadership. We've only got to look back to earlier this year to remember some fairly extreme weather conditions in parts of the country, and certainly I dug myself out of snowdrifts a fair few times on my rounds around farms. And the role of animal health and welfare, and therefore veterinary medicines in climate change, is well recognised. And as part of COP26, UK government has just uploaded a net zero strategy onto the United Nations website. And in this strategy, 368 pages of it, there's specific reference to both decarbonising agriculture, but also looking at how improved animal health and welfare is an important part of reducing emissions, and therefore control and elimination of disease is part of that. So let's have a look at two key aspects of climate change impacts and food animals. Firstly, looking at patterns of disease and how they're changing, and secondly, on use of veterinary medicines. If we look at emerging disease threats, climate change is having an impact on exactly how these are being experienced, and this is prompting changes in how medicines are deployed, but also the need for new medicines. And then secondly, animal health and welfare are important in actually mitigating against climate change, as we look to balance sustainable food production with impacts on the environment. Control of endemic diseases and reproduction are important routes to mitigation for UK livestock, and that's particularly associated, of course, with use of medicines. So looking at some emerging disease threats, just to pick a few of these: Schmallenberg disease, Bluetongue virus, Babesia, Q fever, and liver fluke. So first of all, Bluetongue virus, and particularly Bluetongue virus 8. There are globally around 24 serotypes of the virus, and the UK outbreak more than 10 years ago now was serotype 8. It was originally endemic in Africa, but as a result of warmer climates, the virus spread through Northern Europe and has done so since that initial outbreak in 2006. It was believed to have come to the UK as infected midges were carried across the channel on strong winds. National vaccination was a really important strategy, and deploying that in order of regional risk was very successful in eradicating Bluetongue 8, and it has significant trade implications, so that was important. An effective regional voluntary emergency vaccination programme took place to manage that risk. Schmallenberg virus first was identified in 2011, and the disease subsequently spread widely throughout Europe via infected midges. During 2012 and 2013 lambing and calving seasons, there were numerous cases of congenital defects in lambs and calves, and this was due to in utero exposure to SBV in UK flocks and herds. In the summer of 2016, Schmallenberg virus re-emerged, and so again we saw the birth of typically affected lambs and calves that following year. In sheep and cattle, we see congenital deformities, and also acute disease with Schmallenberg is reported, and associated with clinical signs of milk drop, fever and diarrhea, also in dairy animals too. Vaccine availability in the UK can be intermittent, and this is a factor obviously in opportunities to control in the future. So a third emerging disease of interest is Babesia, known as Redwater, which is a tick-borne disease. The Animal and Plant Health Agency is actually involved in projects and surveillance to try and understand actually kind of where Redwater extent is in the country. Typically there are regional hotspots of Babesia basically in the UK. There isn't a commercial vaccine available, and there is some intermittent import basically from continental Europe. chemical control is limited and is quite quite toxic and high impact, basically medicines available to do that. And then our fourth emerging disease is Q fever. And Q fever is caused by the gram-negative intracellular bacteria Coxiella burnettii. Most infections are asymptomatic, but it can cause late abortions, and there are emerging concern actually regarding quite how significant it is for infertility. It's tick-borne again. It's endemic in the UK, and around 70% of a sample of dairy herds tested PCR positive for basically for Q fever. It has changed in status, and there will be increased emphasis on surveillance, and there's a new vaccine available in the UK actually since this year. And yet, if we look perhaps to our next key emerging disease, it's very directly related to climate change impacts. And if we look at liver fluke and how it spread eastwards in the country as potentially kind of flooding is associated with diagnosis, we can see how that increase in diagnosis has occurred just during this window of time from veterinary laboratory diagnosis. And actually, what's become apparent is that the emerging challenge is responsible for increasing numbers of diagnosable conditions, and we're seeing the impact really of liver fluke only on the increase. Why this is so significant is the intermediate host snail, Galba, is therefore associated with wet conditions, and so liver fluke is determined primarily in its distribution by those climatic conditions where they favour the host snail. So warmer weather and more rainfall is a really important risk factor for liver fluke, and longer grazing seasons exacerbate that problem as animals are unable to graze for larger periods of the year because of milder weather. And we saw really significant step changes in emergence of liver fluke on the back of particularly wet years such as 2012, and liver fluke appearing in regions of the UK that hadn't particularly been associated as being endemic. And liver fluke's got a global economic impact on the livestock industry, because carcass condemnation due to liver fluke is very significant, and can look at kind of losses of more than £1 million in terms of UK industry alone. And certainly we're looking at millions of pounds potentially losses in terms of productivity, both due to mortality but also lost production as well as condemnations. A key issue in terms of veterinary medicines is that we have emerging resistance to flukicides, and also the fact that residues for flukicides are very significant and therefore require significant withdrawal periods in the livestock industry. Flukicides have specific and restricted periods of activity, and not all products are active against all stages of liver fluke. Some are only effective against adults, and less products available at immature and particularly early immature stages. So preventing resistance and managing emerging resistance is important when we have a small portfolio of products that are effective. So in summary, flukicides are emerging as an increasingly important class of veterinary medicines because climate change is contributing to wider distribution of liver fluke and therefore important threats to cattle and sheep farming. There is a lack of robust alternatives to control liver fluke other than relying on chemical control. There's very significant challenges in managing wetlands and available access to pasture that's clear of fluke, so resistance concerns are very significant. It's important, of course, therefore, that education on appropriate use of products and respect for withdrawal periods is kind of really prioritised to avoid inappropriate residues, and also ongoing research into alternative methods is important. So looking at the second part of this talk, really, in understanding how effective use of veterinary medicines can help mitigate climate change, then it's important that we actually look at opportunities to use herd health management to mitigate climate change. And the Chadwick report back in 2007 highlighted key priorities around increased productivity, increased fertility, improved management of nutrition through quality forages, strategic use of feed additives such as rumen supplements, as well as strategic use of dietary oil as well, and new technologies such as vaccination potentially against pathogens. And there are key aspects of productivity here. We can reduce emissions intensity of greenhouse gases by actually improving productivity and reducing waste. So longer lasting cows and precision medicine are really important in actually reducing greenhouse gas emissions intensity and contributing to the fight against climate change. And therefore we should recognise that a big cause of waste is disease, and vaccines are responsible for control of many cattle diseases as well as other livestock diseases in the UK. And this list of vaccines here shows how important vaccines are in control of disease, and therefore what an opportunity they represent if they're used correctly, if they're used in terms of the right time, in the right animals, and also with appropriate storage, particularly cold chain management. Reproductive disease is also really important, and overall reproductive management, because again, huge contribution to productivity and therefore reducing the waste of infertility. And many key livestock diseases have an impact on fertility, and therefore their control is extremely important in terms of, again, mitigating climate change impacts. So I spoke at COP25 in Madrid in December 2019, actually presenting some work with colleagues from Chile and Kenya in actually looking at how mitigating animal health disease, and in this case specifically dairy cattle, has got a key role to play in actually reducing greenhouse gas emissions intensity. And with kind of co-authors including Adrian Williams from Cranfield, we basically looked at how reducing endemic disease can have a really significant benefit on reducing greenhouse gas emissions by looking at decreased mortality, looking at mitigating the impact on milk production and waste from discarded milk, as well as diminished performance such as infertility. We looked at three specific areas: reproductive performance, a single agent infectious disease example, which was BVD, and a multifactorial or management disease, which was mastitis. And by looking at how in these three countries, in the UK and in Kenya and in Chile, we could deploy key animal health intervention measures, such as early pregnancy diagnosis, use of heat detection tools or fixed time programs, we could actually mitigate greenhouse gas emissions intensity impacts. And exactly the same with BVD, which is a globally significant infectious disease of cattle, critically looking at vaccination as well as other measures around biosecurity. And finally, looking at an example of a multifactorial management disease such as mastitis, and again looking at veterinary medicines as an important part of this, such as in dry cow therapy and also teat disinfection hygiene, as well as education around milking time management. And these changes were significant in actually reducing the impact both for the average herd in these countries, but also really importantly looking at the reduction in emissions intensity for the worst performing 10%, where there could be very significant improvements. And this is important if we actually compare with the impact that those veterinary interventions have. And the reality is that there are very, very big returns on quite small impacts on the environment for deploying veterinary medicine. The benefits are very significant. For example, in saving a beef cow giving birth, we can save really significant amounts of carbon compared to actually what it can cost to achieve that change. There are some important policy changes and opportunities that are coming into kind of the UK livestock area, and in England the animal health and welfare pathway is an opportunity from next spring in 2022 to actually deploy public money to support improvement in animal health and welfare and directly link that with greater sustainability. And the four key areas actually: support for an animal health and welfare review, support for control of those endemic diseases, as well as access to grants for both technology and infrastructure, and finally moving towards a system of payment by results for enhanced welfare too. Because what's really important is that we balance these needs in achieving greater sustainability, because we do need to look at all aspects of food security and what that means in terms of resilience of food supply, not just in the UK, but globally. We need to therefore manage and maintain animal health and welfare in achieving that, but also understand implications for One Health, including antimicrobial resistance, in delivering this balance. And then finally, of course, understanding the impact that all of these changes and opportunities have on the environment. Thank you very much.